perforated bottom, which is brought over a cold current of air. The object of this refinement is to stop the roasting instantly and prevent even a suspicion of burning. After the roasting, the shell is brittle and quite free from the cotyledons or kernel. The kernel has become glossy and friable and chocolate brown in color, and it crushes readily between the fingers into small angular fragments, the "nibs" of commerce, giving off during the breaking down a rich warm odor of chocolate. D. Removing the shells. It has been stated that it was formerly the practice not to remove the shell. This is incorrect. The more usual practice from the earliest times has been to remove the shells, though not so completely as they are removed by the efficient machinery of to-day. In a curious treatise on the nature and quality of chocolate by Antonio Colmenero Ledesma (1685), we read, "And if you peel the cacao and take it out of its little shell, the drink thereof will be more dainty and delicious." Willoughby, in his Travels in Spain (1664), writes, "They first toast the berries to get off the husk," and R. Brooks, in the Natural History of Chocolate (1730), says, "The Indians roast the kernels in earthen pots, then free them from their skins, and afterwards crush and grind them between two stones." He further definitely recommends that the beans "be roasted enough to have their skins come off easily, which should be done one by one, layering them apart; for these skins being left among the chocolate will not dissolve in any liquor, nor even in the stomach, and fall to the bottom of the chocolate cups, as if the kernels had not been cleaned." That the Indian practice of removing the shells was followed from the commencement of the industry in England is shown by the old plate which we have reproduced on page 120 from Arts and Sciences. The removal of the shell, which in the raw condition is tough and adheres to the kernel, is greatly facilitated by roasting. If we place a roasted bean in the palm of the hand and press it with the thumb, the whole cracks up into crisp pieces. It is now quite easy to blow away the thin pieces of shell, because they offer a greater surface to the air, and are lighter than the little compact lumps or nibs which are left behind. This illustrates the principle of all shelling or husking machines. E. Breaking the bean into fragments. The problem is to break down the bean to just the right size. The pieces must be sufficiently small to allow the nib and shell readily to part company, but it is important to remember that the smaller the pieces of shell and nib, the less efficient will the winnowing be, and it is usual to break the beans whilst they are still warm, to avoid producing particles of extreme fineness. The breaking down may be accomplished by passing the beans through a pair of rollers at such a distance apart that the bean is cracked without being crushed; or it may be effected in other ways, e.g. by the use of an adjustable serrated cone revolving in a serrated conical case. In the diagram they are called Kibling cones. F. Separating the germs. About 1% of the cacao bean fragments consist of germs. The germ is the radicle of the cacao seed, or that part of the cacao seed which on germination forms the root. The germs are small and rod-shaped, and being very hard are generally assumed to be less digestible than the nib. They are separated by being passed through revolving gauze drums, the holes in which are the same size and shape as the germs, so that the germs pass through whilst the nib is retained. If a freakish carpenter were to try separating shop floor sweepings consisting of a jumble of chunks of wood (nib), shavings (shell), and nails (germ) by sieving through a gridiron, he would find that not only the nails passed through, but also some sawdust and fine shavings. So in the above machine the finer nib and shell pass through with the germ. This germ mixture, known as smalls, is dealt with in a special machine, whilst the larger nib and shell are conveyed to the chief winnowing machine. In this machine the mixture is first sorted according to size, and then the nib and shell separated from one another. The mixture is passed down long revolving cylindrical sieves, and encounters a larger and larger mesh as it proceeds, and thus becomes sieved into various sizes. The separation of the shell from the nib is now effected by a powerful current of air, the large nib falling against the current, whilst the shell is carried with it and drops into another compartment. It is amusing to stand and watch the continuous stream of nibs rushing down, like hail in a storm, into the screw conveyor. This is the process, in essence. To follow the various partially separated mixtures of shell and nib through the several further separating machines would be tedious. It is sufficient for the reader to know that after the most elaborate precautions have been taken, the nib still contains about 1% of shell, and that the nib obtained is only 78.5% of the weight of raw beans originally taken. Most of the larger makers of cocoa produce nib containing less than 2% of shell, a standard which can only be maintained by continuous vigilance. The shell, the only waste material of any importance produced in a chocolate factory, goes straight into sacks ready for sale. The pure cacao nibs, once an important article of commerce, proceed to the blenders and thence to the grinding mill. G. Blending. We have seen that the beans are roasted separately according to their kind and country, so as to develop in each its characteristic flavor. The pure nib is now blended in proportions which are carefully chosen to attain the result desired. H. Grinding the cacao nibs to produce mass. In this process, by the mere act of grinding, the miracle is performed of converting the brittle fragments of the cacao bean into a chocolate-colored fluid. Half of the cacao bean is fat, and the grinding breaks up the cells and liberates the fat, which at blood heat melts to an oil. Any of the various machines used in the industries for grinding might be used, but a special type of mill has been devised for the purpose. In the grinding room of a cocoa factory one becomes almost hypnotized by 100 of these circular mill stones that rotate incessantly day and night. In Monsieur Fry's factory the giddy motion of the whirling mill is very much increased by a number of magnificent horizontal driving wheels, each some 20 feet in diameter, which form, as it were, a revolving ceiling to the room. Your fascinated gaze beholds 2 or 3 vast circles that have their revolving satellites like moons, each on its own axis, and each governed by master wheels. Watch them for any length of time, and you might find yourself presently going round and round with them until you whirled yourself out of existence, like the gyrating maiden in the fairy tale. In this type of grinding machine, one millstone rotates on a fixed stone. The cacao nib falls from a hopper through a hole in the center of the upper stone, and, owing to the manner in which grooves are cut in the two surfaces in contact, is gradually dragged between the stones. The grooves are so cut in the two stones that they point in opposite directions, and as the one stone revolves on the other, a slicing or shearing action is produced. The friction, due to the slicing and shearing of the nib, keeps the stones hot, and they become sufficiently warm to melt the fat in the ground nib, so that there oozes from the outer edge of the bottom, or fixed stone, a more or less viscous liquid or paste. This finely ground nib is known as mass. It is simply liquefied cacao bean, and solidifies on cooling to a chocolate-colored block. This mass may be used for the production of either cocoa or chocolate. When part of the fat, cacao butter, is taken away, the residue may be made to yield cocoa. When sugar and cacao butter are added, it yields eating chocolate. Thus the two industries are seen to be interdependent, the cacao butter which is pressed out of the mass in the manufacture of cocoa being used up in the